Okay, so notes 9.5 is going to be solving exponential equations. And we've got two things going on. So solving equations, we're going to look at two methods. And one is much more simple than the other. So the first one that we're going to look at here is going to be our same base method. And this is what we have been doing so far in this whole unit. So our same base method, very simply, get the same base on both sides. And then set the exponents equal. All right, so like I said, this is exactly what we've been doing. These are just going to get a little harder now. And they're really not harder, it's just that we're adding more garbage up in the exponent. So I have an 8 and I have a 4. So my only base I can have here is 2. I cannot have a base of 4 because 4 squared is 16, not 8. So I'm going to convert these to 2's right away. So I have 2 to the negative 3. 2, 4, 8 is 3. It's in the denominator, so it's negative 3. Now I'm going to put this x plus 1 in parentheses because this value right here, 2 to the negative 3, is this 1 over 8. And then on the right side, to make this a base of 2, that's my goal, I have 2 squared. So now I have same base, so all I'm going to do is set my exponents equal to each other. So I have negative 3 times x plus 1 equals 2. And so now I'm going to solve this just like I normally would. So if I distribute this, I have negative 3x minus 3 equals 2. I add 3 to both sides, so I have negative 3x equals 5. So x equals negative 5 over 3. Okay. Let's try another one. So here I have 27 and 9. So I know right away people think, oh, well, my base is 9 because 9 times 3 is 27, but that's not true because remember we're putting this to an exponent. So my base here has to be 3. So I have 3 cubed. 3 cubed is 27. What's left up here is x minus 4. Now, this one is going to be 3 to the negative 2. So 3 to the negative 2 gives me 1/9. And then that power is 2x plus 1. Okay, so now I have same base. So I'm just going to set everything equal to each other. So 3 times x minus 4 equals negative 2 times 2x plus 1. If I distribute this, and now I solve, so I'm going to bring this over. I end up with 7x equals 10. So x equals 10 over 7. Okay, so one more example, and this one looks a little bit funky. So what happens is we have a fraction and we have a fraction. Hopefully what you see is that 4 squared is 16 and 3 squared is 9. So I have two things going on. The first thing is that my order is flipped. So I'm going to flip this order, and to do that, and this is as low as it goes. So I want to use 3/4. I don't want to build up. I need to bring it down. So this side I'm just going to leave. 3/4 x plus 2. Now my first step is going to be flip this. So I'm going to have 9 over 16, and when I flip it, I have negative 1 to the 3 minus x. Right? So this negative just tells me that I'm flipping the fraction. Okay? Next thing I'm going to do is I'm going to simplify this. So if I took the square root of 9 and if I took the square root of 16, then what happens is I get 3 over 4. So if I look at this value that I have here, 3 over 4, now when I have this number, I can take this and I can take the square root of both of these. So this is the same as saying I have 3 over 4 because that's the base that I want. And this is going to be negative 2 times 3 minus x. So I squared it. So if I square it, I get 9. If I square it, I get 16. It's negative because I had to flip it. And so I turned this into 3 over 4. Okay? So Even though we're taking the square root, to get to that point, I would square it. So when I set these equal to each other, I have negative 6 plus 2x. So if I bring this over, this gives me 8 equals x, and that's my answer. Okay, now let's go to this one, and this is the hard one. So this is our different base method. Now, every one of these that we had on the first side, we were able to find the same base. So we found the same base at 3. Even with this fraction, we found the same base at 3/4. But that's not always the case. We can't always do this. So here's our method. So step 1 is going to be isolate the exponential term. So we want the exponential term to be all itself. Then we're actually going to change this to a log. So we're going to change it to a log by just using our popcorn method. That's all we're going to do. And then we're going to solve for x. Okay, so here's what I have. So this is isolated. So step 1 is already done. My exponential term is all by itself. And the difference is here it's isolated, here it's not. I've got this minus 10 and I've got this 2 hanging out. So I've got to take care of those. But this is isolated. So the next thing that I'm going to do is change this to a log. So remember, this right here is my base. It is whatever is to the base of the exponent. So if that's my base, then if I convert this, I have log base 10 of 4 equals x plus 1. So log base 10 of 4 equals x plus 1. So now when we solve for x, we're going to move this 1 to the other side. So what I have here is x equals log base 10 of 4 minus 1. And that's my final answer. I just took this 1 and I moved it to the other side. Okay, let's do another one. So step 1 here is going to be isolate. That's what we need to work on first. So I'm going to have 2 times 5 to the 3x equals 14. So then I have, excuse me, goodness, 5 to the 3x equals 7. Sorry, y'all. Okay, so now I have my exponential form isolated. So this is my base. So this becomes log base 5 of 7 equals 3x. Okay, so now I'm solving for x. So to solve for x, since I'm multiplying here, I have to divide both sides by 3. So my final answer is log base 5 of 7 divided by 3. And I know that that's not pretty, but there's no way I can make a 5 equal a 7. There's no way. Up here, there's no way I can make a 10 equal a 4. So I can't do that. So I have to do this change of base. Okay, last one. 7, 2x minus 3, and this is going to be equal to 11. Okay, 7 cannot turn into 11. So this is my base right here. So I'm going to have log base 7 of 11 equals 2x minus 3. All right, so opposite operation, so I'm going to add 3. So I'm just going to change my order because my brain likes that better. Right, so all I did was I added 3 to the other side, and then my last step is I divide. So my final answer is going to be log base 7 of 11 plus 3 divided by 2. Okay, now we'll practice more of these in class. But make sure when you're doing this, you just confirm that you can't get the same base, and when you can't, then you're just going to popcorn this. Base of 7 to the 11 equals 2x.